Hello, welcome back to the channel. So the problem of the day is earliest finish time for land and water right 2. It is a follow-up question of yesterday's problem, and the constants given here is 5 into 10 to the power 4. Whenever the constant are 10 to the power 4, it always hint towards big of n log n and log n. Now coming back to the intuition part, we have given land start time and land duration and we have sum of them. So why do I select 6? Because it became an optimal choice of selection, because now player has plenty of time to enjoy other rides in different category. Let's say if I select 9 instead of 6, so the time before 9, just like 7 and 8, if in the water category, if there is some start time present at 7 or 8, so the 9 will wait in that category, but 6 became an optimal choice because 7 and 8 present in the water category. Water start time gives the chance of 6 to perform freely with them. Now try run with an example. So we have given the land start time, which is 289, and the land duration, which is 412, and I have sum of them, which is 6, 9 and 11. And similarly we have given the water ride, which has water start time and water duration, and I have sum of them. As I told you earlier in the intuition part, we will just select the minimum because it's an optimal one. So I have select 6 and I will store in a variable named land time, which defines the land ride. Okay, and it is equals to the land start time plus land duration, which is the 2 plus 4. Now I will compare it with all the rides present in the water category. There are two conditions which will arise. If land time is greater than equals to the water start time, here 6 will compare with the water start time, which is gonna be 6, so it is greater than equals to the 6. So we will just add land time plus water duration, which is 6 plus 3, which is give us 9, and we will store that in a mini variable after compare with the previous value. And the another condition, which is 6 if it is less than the water start time. I mean to say that we have given the land time, which is 6, and we have given the water ride, which here is 8,3. 8 defines water start time and 3 means water duration. So here land ride is stopped or end at 6 seconds. Now it has to wait plus 2 seconds in order to attend the water start time of this ride. After that it can enjoy for 3 seconds, which is gonna give us 6 plus 2 waiting seconds plus duration, which is gonna give us 11. So in this example I have just mentioned that if land time is less than the water start time, so we will just gonna store it in a mini water start time plus water duration, as I have shown you earlier. Now coming to the code part. Now I have defined n equals to the land start time. It just says the length of the land ride, and the m defines the length of the water ride. Here the variable minimum L2W means when I will compare with the water rides, and M2W and W2L means when I will compare to the land rides. Now I define land time and the water time. Land time means when the land ride will over and the water ride will over. I am talking about the minimum, the optimal ride. So I have stored both of them in the land time and the water time. Now I have moved over the water rights, and as I told you before, there are two cases that I will face. The case one is when land time is greater than equals to the water time, and as I have told you before, and the similarly goes with the case 2 when the land time is just less than the water start time, so we have to wait for some second. So we have just added the water start time plus the water duration, and here in this area I have just performed similar with the land rights. That's why I have used minimum w to l. At the end I will return the minimum of both, minimum of the code is in the GitHub. Check it out in the description. Do not forget to like, share and subscribe.